counting principle is used to find the number of different ways an event can occur. So when there are m ways to do one thing and n ways to do another, then there are m times n ways of doing both. Okay, so you multiply the total number of ways that's available for the first thing times the total number of ways that are available for the next thing. So, for example 1, Joan goes to the snack bar to buy a bagel and a drink for lunch. She can choose a plain bagel, a blueberry bagel, or a raisin bagel. The choices for a drink include water or a sports drink. How many different lunches could be made with these choices? Draw a tree diagram. So a tree diagram is another method that you could use for the counting principle. So how many different bagel options do we have? 3. So you have your plain bagel, your blueberry, and your raisin. Okay, and with your bagel you can have what to drink? Water or a sports drink. Okay, so when you use a tree diagram and you go left to right, the total number of possibilities you have on the right-hand side, okay, so farthest right, is how many total combinations you could have. So we have 1, 2, 3, 4, 5, 6 total combinations. Okay, another way to find that is by using your counting principle. Okay, for our bagels, we had a total of 3 possibilities. For our drinks, we had a total of 2 possibilities, and 3 times 2 equals 6. So obviously it's way easier to use the counting principle. However, if you need to see it visually, you can always make a tree diagram. Okay, so number 2, when Bobby gets ready for school, he opens his closet to find the following choices: red, blue, or white shirt, jeans or sweatpants, and tennis shoes or sandals. How many different outfits could be made with these choices? Okay, how many choices do we have of shirts? 3. How many choices of pants? How many choices of shoes? So, how many total different outfits could we make? 12. Okay, so this is how you figure out the total number of combinations using the counting principle. Questions on that? Pretty simple. Okay, blank is a way to measure the likelihood of an outcome. What do you think goes there? Probability. Probability is a way to measure the likelihood of an outcome. Okay, and to find the probability of an event, you take the number of ways that that event can occur over the total possible number of outcomes. Okay, so the number of ways the event can occur over the number of possible outcomes. Okay, a few rules must apply. In order for if the probability of an event equals 0, that means that that's an impossible thing. Okay, so for example, I can't pick out of this classroom a student that is taking science 4th period on A days, because all of you are taking math 4th period on A days. So the probability of that would be 0, which means it's impossible. Versus the probability of an event equaling 1 means it's 100% going to happen. So if I look around and I say, what's the probability that a student in here has Coach Cologne 4th period on A days? All of you do, so it's 100%. Okay, and then all probabilities should be between and will be between 0 and 1, because as we just saw, chances are it's not going to be 0 and chances are it's not going to be 1. Okay, so it should be 0 to 1, and it's usually represented by a percent. Okay, there's a 30% chance that it's going to rain today, whatever. Questions on just the basic intro there? Okay. Hey, as you can see, we got these notes from Wakeland, because the student body at Wakeland High School is broken down as follows. Okay, there's X amount of freshmen, sophomores, juniors, and seniors. If one student is selected at random, what would be the probability that the student will be a junior? So you're looking for the probability of a junior. How many total juniors are there? 557. What number needs to go on bottom? Total number of students, which is 2,180. Can that fraction be simplified? Can it be reduced? No. So you could leave it as that, or you can convert to a percent. What would it be? So it's about 25%. Which would make sense because it's a quarter of your school because you have 4 grade levels. Okay, an event is blank if its outcome does not affect the outcome of another. What do you think goes there? Independent. Who would have known that bold word is right below? Independent. So if A and B are independent events, then the probability of both of them happening is the probability that one event happens times the probability of the other event happening. Okay, so for example, number 1, a fair coin is flipped 3 times. What is the probability that every flip will land on heads? So we're looking for the probability that you get 3 lands on heads. But what's the probability that you get heads the first time? Half. What's the probability you get heads the second time? Half. What's the probability you get heads the third time? Half. Oops, running out of room. So what's 1/2 times 1/2 times 1/2? 1/8. So you have a 1 in 8 chance of getting heads 3 times. A player rolls a dice twice. The number which the dice lands on the first time is X, the second time is Y. What is the probability that the product of X, Y will be greater than 20? How on earth do I fill out this table? You multiply the number on the top times the number on the bottom. It's just like your traditional times tables when you were a kid. So you have 1 times 1, 1 times 2, 1 times 3, and so on. And then you move down, 1 times 2, 1 times 3. And then you just keep going across. Now you have 2 times 2, 2 times 3, and so on. And then when you're finished, highlight all the numbers that are greater than 20. If you don't have a highlighter, you can just circle them. How many total squares did you have? 36. And how many greater than 20? So what is your probability? 1/6. You always want to make sure your probabilities are reduced, if possible. Questions on independent events? Okay, an event is blank if its outcome affects the outcome of another. Dependent. Okay, a key word for a lot of dependent events is if it says, like, I picked a card and then I didn't replace it. Okay, so a key word is without, or words without replacement. Okay, and if A and B are dependent events, then the probability of both of them happening is the probability that A happens times the probability B happens once A has already occurred. Okay, so, for example, number 1, 2 cards will be drawn from a standard deck without replacement. Okay, those are those keywords I told you to look for. Okay, what is the probability that both cards will be read? Okay, last year when we were doing this lesson, it was crazy what little knowledge you guys have about a deck of cards. How many cards are in a deck? 52. Ever heard the game 52 card pickup? Yep. Yeah, somebody has pulled that joke on you before. Okay, how many red cards are there then? 26. How many suits are there? 4. How many cards are in each suit? 13. How many face cards are there? 3. Okay, good, very good. Y'all know more than last year. Okay, so you have total cards is 52, red cards is 26, and we need the probability that both cards will be red. So we want 2 reds, but one of them has to be done without replacement. So you have the probability of red times the probability of red given a red has already been pulled. Okay, what is the probability of a red? 1/2, or 26 over 52, right? Okay, what would be the probability of picking a second red if I didn't replace the first red? 25 out of, not 52, 51, because you're assuming that not only did you pick a red card, but you obviously had to pick a card from the whole deck, which is why it went from 52 to 51 cards. Okay, so this simplifies to 1/2, correct? So what would be the probability? (25 over 102). So 51 times 2 is 102. Yes. Because that's what I'm trying to figure out, that both of them were red. It says, what's the probability that both cards will be red? Okay, number 2, a box contains 5 purple marbles, 3 green marbles, and 2 orange marbles. 2 consecutive draws are made from the box without replacement of the first draw. Find the probability of each event. Okay, so we want the probability that orange is first, green is second. So if I rewrite it into the format above, I have the probability of orange times the probability of green given that orange was first. Okay, what is the probability that, can't spell. The probability that I pull an orange? 2 out of 10. Okay, so what would be the probability that I pull a green now that I already have an orange sitting off to the side? 3 out of 9. So the orange didn't affect the number of green marbles, but it affected the total number of marbles that were left in this bag, or box. Okay, so I have 3/9 times 2/10, so 2/10 simplifies to 1/5, 3/9 simplifies to 1/3, so what are you left with? 1/15. Okay, letter B, both marbles are purple, so you have the probability of purple times the probability of purple given purple. Okay, what's the probability of purple? 1/2. So what would be the probability of a second purple? 4 over 9. So what is your probability? 4/18, which divide both by 2. 2 over 9.
Wait, why did you change the 4 to 2 and the 2 to 1?
You just cross cancel. 2 is a multiple of 4. So 2 times 4 is the same thing as 1/2. Okay, C. P, the probability of the first marble is purple, and the second is any color except purple. Okay, so you have probability of purple times the probability of not purple, which is the same thing as this little sign here, if you want to write that. Just not purple given purple. What's the probability of purple? 1/2. So what would be the probability of not purple given that you pulled a purple? 5/9. And what do you get? 5 over 18. Any questions about independent, dependent, or the counting principle?